This is going on page 60, and we're going to look at domain and intercepts of our rational functions. You okay? Okay. Domain and intercepts, we looked at the asymptotes and stuff. We're still going to talk about those a little bit because we're going to kind of look at all this together. But first, we're going to revisit slant asymptotes. Okay, those are brand new to you, so we're just going to look at another one because there was a picture here I wanted you to see without us graphing it, and let's talk about a few things. So what's another word for the slant? Oblique. Very good. So it's oblique. So for any of these that we do, we have to start by factoring this. So if I factor this, I'm going to get x, what? I get an x and an x. X minus 4 and x minus 3? Do I agree with that?
X minus 3, x minus 1.
Yes, please go get some water. Okay, minus 1 and minus 3, yes. Oh, I heard minus 4 and minus 3, sorry. Okay, I was like, I don't know where the 4 is coming from. Okay, yes, minus 1 and minus 3, or minus 3 and minus 1, that doesn't matter, over x plus 2. All right, so do I have any point discontinuity? No. Okay, so we're just going to find some stuff out about this. I do not have any point discontinuity. Do I have any vertical asymptotes? Yes, I have a vertical asymptote. X equals negative 2. Do I have a horizontal asymptote? No, right? Because it is top heavy. Do I have a slant asymptote?
Yes.
Yes, I do. Yes, I do. I like the enthusiasm. Okay, yes, I do. And so we have to go figure out what it is, and in order to do that, we have to do what? How do we figure out the slant asymptote? Do you remember? I can use synthetic division. I'm going to have to divide. If I can use synthetic division, I want to use synthetic division, which I can. If not, I have to use long division. So I'm going to use synthetic division. Negative 2 goes on the outside. And then on the inside, I'm going to pull from here, obviously. So this is 1, negative 4, and 3. So this is 1, negative 2, negative 6, 12, and 15, right? And what did we do with our remainder when we got to our slant asymptote? We threw it away. Okay, so we're going to look at what it actually means. Like we're still not going to use it, but it does tell us something. So let me write this in here first. So our slant asymptote that we get is y equals x minus 6, right? And we just ignore the remainder. Would you agree with that? So then I'm going to take this, my original one here, and I'm going to rewrite it right here. So f of x is equal to x squared minus 4x plus 3 over x plus 2. What I got from here from my synthetic division was x minus 6. And if I actually got the whole thing, like when we did synthetic division before, that'd be plus 15 over what? X plus 2 over the divisor, right? X plus 2. Aren't these two things equal? Just think about that for just a second. When we were just doing straight up synthetic division, and I told you, divide, right? And you went and you divided, and you gave me an answer that looked like that. That's because when you actually divide this polynomial by this one, this is what you get, remainder and all. That makes sense to you? That is the reduced version. If I wanted it back in this form, then I get common denominators, and I add them together, and it'll look like this again. But this is just this reduced. These are the exact same thing, okay? But that's one reason why I don't use the remainder, because if I used it, I'd be graphing this and not actually graphing a line, right? Because this is not linear, it wouldn't graph a line. Okay, so then let's look at what this little piece right here actually tells us. Okay, so our remainder, just the remainder part, is this 15 over x plus 2, right? That's your remainder. I think we all get that, right? So let's look at this graph here. This is a graph of that function. Here's my vertical asymptote. Here's my slant asymptote. So, and then this is the, the little function with my zeros and stuff in there that I've graphed. That 15 over x plus 2 does tell us something. Remember, the asymptotes, this function is going to get closer and closer and closer to that asymptote as x goes to infinity. Well, if you look at this, so in this, you're counting, this is my, so I've got to find the 0, and then I think we're counting by 5s. Wait, my vertical asymptote is at negative 2, so this is, I think this is 0. So 1, 2, 3, 4, 5. I guess we're counting by 4s. So this is between 0 and 4. So when x is 4, I guess it doesn't even matter, but if you just look at the distance here, you see how the distance between the graph and the asymptote gets smaller and smaller and smaller as you go, right? Because as x gets bigger, so whatever I substitute in for x, with this denominator here, as x gets bigger and bigger and bigger, doesn't this fraction get smaller and smaller and smaller? Right? That's what happens. So when we talk about limits, which we haven't yet, but we will, the limit of this as x approaches infinity is going to be 0, because the bigger and bigger and bigger that this number gets in the denominator, the smaller and smaller and smaller that fraction gets. This right here, what this represents is the distance between the function and its slant asymptote. Okay, so that's what that remainder is. If I use it on there, then I don't really have a line. I'm getting the actual function there, because that's what I get when I divide. But just the remainder itself is the distance, and it gets smaller and smaller and smaller, and it never actually touches that, but that's what it's approaching. So that's what it is. We're not going to use it. Like, we talk about this is what it does, and you can do stuff with it later. We need to know how to find it. We ignore the remainder, because if we don't, then we don't have a line. And the remainder that we're ignoring, because it'll be different for every problem, right? Whatever that remainder is just the distance between the function and the line. Okay? Does that make sense? It's just kind of like a little FYI. So you don't wonder why we just throw it away and it means nothing. It does mean something, we're just not really going to use it. All right, so let's talk domain and intercepts, which is what this is really about. So domain of a function. We know how to find domain, right? It's the set of what? What is domain for us? All the x's. It's the set of all the x values for the function, yes. So domain, when you find this first, it's the first thing you do before reducing. If you do it after you reduce, you may well leave something out, and that will be bad news for you. So you do it first. You may need to factor it to figure it out, but you factor it. You don't cancel anything out. Don't do anything like that. You just find your domain. Your x-intercepts. To find those, what's another word for x-intercepts? Zeros. Another word for x-intercepts is not y, no. It is your zeros, or solutions, or roots, right? So zeros. So you find the x-intercepts. You do after reducing, which means that's after finding the point discontinuity, because that's what happens when you reduce, right? You're finding the holes in your graph. So x-intercepts, or the zeros, are found after that. If I say to you to give me the x-intercepts, what form does your answer have to be in? Never going to be an interval, no. It's ordered pair. So your domain would be an interval, but your x-intercepts would be an ordered pair notation. Zeros is when it's in set notation. So you got to know the difference. They're the same thing on your graph, but you notate them differently when you write them, and those are important things to know. All right, so to find this, that means we're going to find the zeros of which part of my rational, the numerator or denominator? The numerator. So the zeros of the numerator are the zeros of the function. So the y-intercepts, which are also done after reducing, which means it's after point discontinuity. And just like every y-intercept you have ever found, should not struggle with that. You substitute 0 in for what? X, and you solve for y. Every time. And how should these be written? Since it's y-intercepts. Those are always ordered pairs. I know what you mean. You got to get the right words out eventually, but I know what you mean. All right, we all good? So domain, x-intercept, these aren't new concepts. They may be for rationals, but make sure domain is done first. That's the only thing you do before reducing. I know yours doesn't say find the domain down right there. I don't know why mine went to the other page, but that's it. So let's flip it over and see how this is all going to work. Yours says at the top, find the domain, which mine should, but it doesn't for whatever reason. So all we're looking for is domain here. The first thing I need to do for all of these is factor so I can figure out what's happening. So I get x minus 2 over, can I factor this? Yes, that's x plus 2 times x minus 2, because it's a difference of squares, right? Now, can I reduce something here? Yes, but I'm finding domain, so I don't care, right? I have to do it before I reduce stuff. The only thing that affects your domain in rationals are your vertical asymptotes and your holes. That's it. So whatever's happening in the numerator, I don't care. The only thing you look at for domain is the denominator. So the domain of this, okay, this is what we know. We know that the denominator cannot be 0, right? So x plus 2 can't equal 0, and x minus 2 cannot equal 0, right? So the domain is going to be all real numbers except for what? Plus or minus 2, right? And so I write that in set notation. Remember, it's the set of all x's such that x does not equal plus or minus 2. Right? The denominator can't equal 0, but this. Right? So set of all x's such that x cannot equal plus or minus 2. Easy enough? We good? So let's look at number 2. I can't factor anything, right? So the domain is going to be the set of all x's such that x cannot equal what? Negative 11. See how easy that is? It's wherever your vertical asymptotes and your holes are coming from. And then I can factor this one, right? So in the numerator, x plus 3 times x minus 3 over x plus 5 times x minus 5. So my domain is the set of all x's such that x cannot equal what? Plus or minus 5. Okay, easy enough? Okay, can handle that? All right, awesome. All right, so let's find our x-intercepts. But we're actually going to change that, because when it says x-intercepts, what form would my answer have to be in? Ordered pair, but we're going to mark this out and write zeros because I put zeros on the homework and then I forgot to change it on the notes. So there you go. So I'm going to factor the denominator because the numerator I can't factor, and this is going to factor into x minus or x plus 4, x minus 2. Would you agree with that? Yes. All right, so what are my zeros here? Those would not be my zeros. How do I find the zeros of the function? Zeros are the numerator. So what's the only zero of the numerator? Negative 2. So my x values, which as zeros, those are going to be in set notation, it's negative 2. That's all I've got. That's the zero of the function. So there's only one. So on number 2, I'm going to factor that. It's going to give me x minus 5 times x plus 4 over x plus 4 times x minus 4. Okay, can I reduce anything? Yes. Now when I do, even though we're just talking x-intercepts here, I have to notate that that's point discontinuity. That's point discontinuity with an x value of what? Negative 4. Okay, so my reduced function is f of x equals x minus 5 over x minus 4. Because remember, this in itself is not a true statement. This isn't the function. The function is this with a hole here, right? Because we knocked that out, so that's why we have to mention it. So then my y value for my point discontinuity is, I get negative 4 minus 5 over negative 4 minus 4. So what's that going to give me? Okay, 9 over 8, is it positive or negative? Positive, yeah. 9 over 8. I wasn't sure what I heard. All right, so then I still have to answer the question. My zeros then are going to be what? Positive 5. There's just one of them. Okay. Everybody good? All right, so then number 3. I can't factor anything. I can't reduce anything. I need my x's. Or is it 0? There's none, right? I don't have any. So the way I show that I don't have any in set notation looks like this. Right? So tell me about this set. What's wrong with it? It's empty, right? It's called the empty set. Right? So there's a little side note, because I know empty set is not something you've necessarily seen, but empty set can mean, you can write it like that, which is literally a set that is empty. Think about that. Or that. It's like a 0 with a line through it. It's not vertical. It's not like the Greek letter phi. That is not a 0. So those of you that are writing it like that, I'm going to start counting everything wrong every time I see it, because you are saying something that does not make any sense at all. Here's what you don't do also. This right here is a big fat no. Because what this is a set that contains the empty set. Right? You're like you're saying it twice, and which is a thing when you get into logic and whatnot, but that's not the same thing as just the empty set. So if your set of x's is empty, you literally make it empty. Okay? No, because that's set notation. None is not set notation. Notation. We got to learn the correct notation here. All right. So then let's look at 4. I'm going to factor it. This is going to give me x minus 4 times x plus 2, right? Over x plus 3 times x minus 3. Nothing cancels, right? So my zeros are what? Okay, so negative 2 and positive 4. That is set notation, yes. It should be in order, yes. When you throw in the plus or minuses, it throws the order off. It makes it a little weird sometimes to know where to put what, but for the most part, they should be in order, yes. Okay. We good? Everybody good? All righty. So let's look at the y-intercepts. So y-intercept is also done after reducing. So I still need to factor and try and reduce if I can. Can I reduce? No. So what I'm looking for is g of 0. So when I substitute 0 in for x, that gives me negative 3 over 11. If you have it all multiplied out, okay, of course, you can't all be multiplied out because you got to factor to see if you can reduce. But when it's all multiplied out, if I just ignore everything with the x's in it, then that pretty much gives me my y-intercept. But my y-intercept then has to be written as what? Ordered pair. Okay. Where does the 0 go, first or second? First. So it's 0 and then negative 3 elevenths. And that's negative 3 over 11. That's what I actually got, right? Can I pull that out to the front and make that negative 3 elevenths? Yes, that's what I just did. Can I make it 3 over negative 11? Yes. Okay, let's do this. Because this is something that y'all get, I don't know what the heck you do sometimes, but this is the same. Be careful how you write it so you can tell where your sign is. That's the same thing as negative 3 elevenths, which is the same thing as 3 over negative 11. Do you see how that negative can be at the numerator, it can be at the denominator, it can be out in front? It just can't be on both. If it's on both, then it cancels out. Does that make sense? So you can write it either way. What we got was negative 3 over 11, but really, when you're talking about it as a fraction, it's negative 3 elevenths. But it's the same thing. Just make sure you know when you can move those things around. All right, so then on this one, I'm going to factor, and I get x plus 3 times x minus 3 over x plus 3. I do have point discontinuity. Very good. So point discontinuity, and the x value would be negative 3. Okay, so I'm going to write that down so I don't forget. Those cancel out. So I get f of x is equal to x minus 3. So the y value for my point discontinuity is negative 6. Then I have to find the y-intercept, which is going to be 0 something. It's going to be 0 what? Negative 3. Good. Because I just substituted in there. You just get your negative 3. Okay. Everybody okay with that? All right, good deal. So then this one. I need g of 0. That's going to be 1 over 0 squared. Is it 1? Is it none? Is it 0? It's what? Error, error, right? Talk about error. Are you allowed to divide by 0? No. So the answer, if that was 0 over 1, the answer is 0. 1 over 0 is an undefined. So I don't put my y-intercept as undefined. I mean, technically it is, but I just don't have any. So this is none, and that's okay here because we're not writing it in set notation. We're just writing it ordered pairs. You don't have any. So it's none. All right, so then we look at number 4. Now, if I want to factor this, can I factor the numerator? No, it doesn't factor, right? So if I can't factor the numerator, I don't even care about factoring the denominator because the only reason I'm doing that is to see if I can cancel something out anyway, right? So since I can't, and what I want is g of 0, when I substitute in 0 for the x's, everything that has an x on it basically just goes away, and I'm left with g of 0 being 11 over negative 4. Do you see how it's easy to just look at that and know what it is? I mean, you might have to reduce, but all you're looking at is the constants. Yeah, because 0 just goes away. So your y-intercept then is 0, negative 11 over 4. Well, because I couldn't factor. If the function doesn't factor. If it did factor, I needed to in case I had point discontinuity. But what happens here is when I substitute that in, I get 0 squared minus 3 times 0 plus 11. And 0. Can't even read that anymore. Is that 9? Plus 9. Okay. Plus 9 times 0 minus 4. So this is just 0 minus 0 plus 11 over 0 plus 0 minus 4. So anytime you substitute a 0 for x, it's just going to 0 out the term. You don't have to do all that. You just jump right to there. We good? Any questions? All right, so go ahead and glue or tape that in, and I'm going to give you your assignment, and we are going to do number 1 together. Now, before you start whining that I'm giving you a packet, okay, everybody else I gave it to, they had to carry it on all day. At least you have me 7th period, and your arms won't fall off. But I took this from something that was one side of the piece of paper. That was it. It was just on the front. And I gave you that. You'd be like, oh, no big deal. But I spread it out so you had plenty of room to work. That's why it looks like that. I could have crammed it all together and made your life more difficult, but I spread it out. But I know anytime you have a stapled thing, it's like, oh, my God, it's a packet. It's like the world is coming to an end. It's all in your head. You wish I'd have just left it on that one page? Oh, no, you don't. Yeah. You better worry about his pre-cal homework is what you better do. All right. Yes. But he was worrying about his history. So he better worry about his pre-cal. But yes, you are in pre-cal. Good job, Rudolph. I'm proud of you for that. We know what class we're in. Yay! We have to put none. Yeah, that's why we're going to do one. Yeah, because not everything's going to have everything. And you're right. Yes. Yes. So the only thing that you don't put none for would be your x's, something you're going to write in set notation. Everything else, none will be okay. And we'll use none a lot. That's a good question. That's why we're going to do one together. All right, so this big blank rectangle that's underneath each one is just your room to work in case you need to, because you might need to factor. You might need to do something, like we'll figure it out. So for number 1, this is what I have here, and I need to factor it. So f of x is equal to, in the numerator, I'm going to get x times x minus 1. And in the denominator, I get x plus 2. Okay? So the first thing I do before I cancel anything if I can, is I find the domain. So my domain is the set of all x's such that x cannot equal what? Negative 2. Right? Because my domain just comes from my denominator. Then I see if I can cancel anything. Can I cancel anything? No. So since I can't cancel anything, I don't have any point discontinuity. Even though that's not the second blank, I can go ahead and put none there. That's the only way you get it, is if you have something you can cancel. Then my zeros, that's in set notation. What are my zeros? 0 and 1. I'm getting those from the numerator, right? Whatever would make those 0. Then my y-intercept, this one's probably a little bit easier to look at in that form instead of this form. If I substitute in 0 for everything, what does the numerator become? 0. If the numerator is 0, does it matter what's happening with the denominator? Nope. So my y-intercept is 0, 0. Do I have any vertical asymptotes? Yes, I have x equals -2. So remember yesterday how when we started that and I was writing x can't equal -2 and then we put x equals -2? This is one reason why I was doing that, and that's what's happening here. Since it can't equal -2, that's why I have a vertical asymptote there. Do I have a horizontal asymptote? What would it be? 1? When it's top heavy, what does top heavy mean? Top heavy is none, yeah. So top heavy is none because I have degree 2 over degree 1, so this is none. And if the numerator is 1 degree higher than the denominator, what do I have then? Slant, okay? And I find that by doing what? It's top heavy, so that's how I know to look. It's division, and I can use synthetic division here. I could use long division, but I'm not going to. So synthetic division, I'm going to get -2 out here. Inside of here, I'm going to get 1, and then what? -1, is that it? You got to have that third piece, right? Because you have a missing term there. So bring this 1 down. We do. Anytime you're missing a constant, we have. Maybe. Or you might have gotten lucky. Sometimes you'll get lucky because then you're not using the remainder or something. You do something weird and you just get lucky with that. So I bring down my 1, and then I'm going to get -2. So this is -3. This gives me 6, and it's 6. And what do I do with the remainder? I get rid of it. I just ignore it. I don't even care what it is. So my slant asymptote is a line. It's y equals, I get it from right here, x minus 3. Okay, we all good with that? Any questions at all? So if there's none, you put none unless it is in the zeros and then you put the empty set. Okay, we good? These should go pretty quickly. They won't take you forever. There is one I'm going to have you eliminate, but I got to go back to my desk and remind myself what it is.